Hello students, today we are going to study errors in leveling. Generally, the errors in leveling is of three types: instrumental error, natural error, manual error. Now, manual errors occurs because of the mistakes done by human beings or by the observer or by the surveyor. Natural error is due to the natural changes, that is due to refraction, curvature, temperature, wind velocity, and instrumental error is due to sluggish bubble. It means that bubble will not be stable and it will move like this. So if the bubble will move like this, then our instrument will not be correctly leveled and the reading will be taken by that wrong leveled instrument will be wrong. Next one is collimation error. Next one is deflected staff. If the staff is deflected like this and we are taking the reading from the level, then the reading will not be correct because of deflected staff. Next one is the faulty joint in staff. Now if the joint in the staff is faulty nature, then we don't get the correct reading from the staff and that type of error comes under instrumental error. That is all about the errors in leveling. Now we can move to the next portion, that is limiting length of offsets. Now what do you mean by limiting length of offsets? The maximum length of an offset is generally determined for the consideration that the error produced in plotting the detail on the drawing sheet should not be significant. In other words, the displacement of the detail on the drawing sheet from its correct position should not be greater than 0.25 mm or so. It means that when we draw an offset and if there will be an horizontal displacement, then it should not be greater than 0.25 mm or so in the drawing sheet. Now one question is there that an offset was laid out 5 degree from its true direction. It means that we have to draw the offset like this, that is AC, but due to some mistake the offset will be laid out at an angle of 5 degree and is measured as capital L, and the scale of the map was 20 meter to 1 centimeter. It means that the 20-meter distance on ground will correspond to 1 centimeter on the sheet. Find the maximum length of offset for the displacement of a point on the paper not to exceed 0.03 centimeter. It means that if the displacement of a point on the paper is not to exceed 0.03 centimeter, then we need to find the maximum length of offset on the ground, that is the value of capital L. Now from this diagram it is clearly seen that sin theta is equals to perpendicular upon hypotenuse, which will be equals to BC upon AB. Now we have the value of theta, that is 5 degrees, so we will mark the theta as 5 degree. Now we want to compute the value of BC, so we will write the BC as it is, and the value of AB is L. So the value of BC will be equals to L sin 5 degree. Now we have the scale of 1 centimeter to 20 meter. It means that 1 centimeter on the sheets correspond to 20 meter on the ground. Therefore L sin 5 degree on ground represents L sin 5 degree by 20 centimeter on the paper. Okay, we had converted the length of the ground or the length which we will measure on the ground with the proper scale so that we can get the value of the length of offset on the paper. Now this is limited to 0.03 centimeter, so we will just write it as L sin 5 degree upon 20 is equals to 0.03 according to the question. Now from this we will compute the value of L. It will be equals to 0.03 into 20 divided by sin 5 degree. On solving this we will get the value of L as 6.884 meter. That will be the maximum length of offset, which should be equals to 6.884 meter if the displacement of a point on the paper is not to exceed 0.03 centimeter. That is all about the limiting length of offsets. Now we can move to the next topic, that is computation of area. Now computation of area is generally done by four methods, that is mid ordinate rule, trapezoidal rule, average ordinate rule and Simpson's rule. Now we will calculate the area one by one, starting with the mid ordinate rule. Now suppose that we have the area like this, that is the survey area, and we want to compute the complete area of this whole figure. Now we will divide this complete area into number of rectangles and triangles like this. But this remaining area, we cannot compute this area by any of the method. So we will calculate this area according to the mid ordinate method, average ordinate method, Simpson's rule or trapezoidal rule. Now suppose that we had marked the total length as small l and we had taken the offsets at regular interval, that is O1, O2, O3, O4, O5 and O6. Now according to mid ordinate rule, we have to compute the value of mid ordinate. Okay, so how can we compute the value of h1, h2, h3, h4 and h5? It will be equals to O1 plus O2 divided by 2. It will be the value of H1. So we will write H1 as O1 plus O2 by 2. Similarly, H2 can be computed by adding O2 plus O3 divided by 2. We can get the value of H2. Now this will be joined by straight lines according to the mid ordinate rule like this. Okay. Now to compute the total area, we will use the formula, that is common distance, which is shown here. That is the distance between two offsets. It is represented by small d. So area will be equals to common distance into sum of mid ordinate, that is h1, h2, h3, h4, h5. So we will write the formula as area is equals to d into in bracket h1 plus h2 up to h5 according to this figure. That will be the mid ordinate rule method for the computation of area. The next method will be the average ordinate rule. Now according to the average ordinate rule, we will calculate the offset, that is O1, O2, O3, O4, O5 and that will be the complete length small l. Now according to the average ordinate rule, the total area will be equals to sum of all the ordinates divided by the number of ordinates into length of baseline. So it will be equals to O1 plus O2 up till On divided by the number of ordinate, that is n into L. Now according to our figure, the total sum of ordinate will be equals to O1 plus O2 plus O3 plus O4 plus O5 divided by the number of ordinate, that is 5 into L, that is the complete length of baseline. This is the average ordinate rule for the computation of area. Now we can move to the next method, that is trapezoidal rule. Now the figure is same, that is O1, O2, O3, O4 and O5 are the offsets and this is the common distance between the two offsets. Now the formula according to the trapezoidal rule for the computation of area will be equals to common distance divided by 2 in bracket first ordinate plus last ordinate plus 2 into sum of other ordinates. So according to the given figure, the formula will be equals to d by 2 in bracket O1 plus O5, that is the sum of first and last ordinate plus 2 into rest ordinate, that is O2 plus O3 plus O4. Now the next formula is the Simpson's rule. Now in Simpson's method, the offsets are not joined by a straight line, but it will be joined by a curve like this, which is shown here. That will be the exact shape. Now this method is used when number of ordinates are odd. This is the most important condition for the implementation of Simpson's rule, that the number of ordinates are odd. Okay, and The common distance between two ordinates or offsets is represented by small d. So the formula of total area will be equals to common distance divided by 3 into, in bracket, sum of first and last ordinate, that is O1 and O5, plus 4 into sum of all the even ordinates, that is O2, O4 in this figure, plus 2 into sum of all the odd ordinates, that is O3 in this figure. Now we will add all these values and multiply it by d by 3. We will get the total area of that figure. Okay students. Now that is the 4 methods for the computation of area. Now we can move to the next method, that is computation of volume according to the trapezoidal rule and according to the prismoidal formula. Now according to the trapezoidal rule, the volume will be equals to common distance divided by 2, in bracket, sum of first area and last area, plus 2 into sum of all the other areas except first and the last areas of cross sections. Okay. Now the next formula is the prismoidal rule. According to this rule, the volume will be equals to common distance divided by 3, in bracket, sum of first area plus last area, plus 4 into sum of all even areas, plus 2 into sum of all odd areas except first and the last areas. Okay, that is the formula for the computation of volume. Now how can we compute the value of areas? So we will use this formula, that is B plus SH upon H. This is the cross section which is shown here. Here B is the width of formation, that is shown here. H is the depth of section, it will vary as the section varies, and S is the side slope. So according to this formula, we can calculate the values of A at regular intervals. Okay students. Now one question is there, that the following perpendicular offsets were taken from a chain line to an irregular boundary. Now chainage is given as 0, 30, 60, 90, 120, 150, 180 and 210. It means that the common distance is equals to 30 always. Okay. Now offsets are also given, that at 0 meter chainage the offset is 0 meter, similarly at 30 meter chainage the offset is 2.65, similarly 3.8, 3.75, 4.65, 3.60, 5 and 5.80. Now the area between the chain line and irregular boundary by trapezoidal rule is, now we have to compute the area of this irregular boundary by trapezoidal rule. Now we know that the trapezoidal rule is common distance divided by 2, in bracket, sum of first ordinate plus last ordinate, plus 2 into sum of all the other ordinates. Okay students. Now we will put the values of all this, that is the common distance is 30 meter. So we will write the value of D as 30 divided by 2, and the first offset is 0 and the last offset is 5.80, plus 2 into all the other offset sum, that is 2.65 plus 3.8 plus 3.75 plus 4.65 plus 3.60 plus 5. On solving this, we will get the area as 790.5 meter square. That will be the area of that irregular boundary which we had computed according to the trapezoidal formula. Okay students. Now we can move to the next portion, that is sensitivity of bubble tube. Now you all had seen the bubble tube like this. This is the bubble and this is the complete bubble tube. Now if we just raise the level tube by an amount theta, that is this, then the bubble will move like this. Okay. So we had drawn the figure like this, that if we raise the level by an amount theta and the reading on the stuff will change from S1 to S2, then the bubble will move like this, and the total movement of the bubble is actually in curved path, and it will be equals to n into L. Okay, and this angle is theta, and this r is the radius of the bubble tube. Now we will compute the value of theta from both this diagram, that is from this diagram as well as this diagram. Here r is the radius of curvature of bubble tube, which I had already told to you. L is the length of one division of bubble tube, which is shown here, that is this. S1 is the staff reading taken at a distance d, instrument keeping bubble at center. When the bubble is at center, the staff reading is S1, and when the instrument is rotated by n division, the staff reading is S2, which is shown here. So the staff intercept will be equals to a difference between S2 and S1, so it will be equals to S, that is S2 minus S1. Now as theta is very small, we can just say that theta will be equals to S by d, because tan theta will be equals to perpendicular upon base. Perpendicular is S and base is d, which is shown in this diagram, that is S and d. But theta is very small, so we can write it as theta is equals to S by d. Similarly, from this diagram, it is clearly seen that theta will be equals to arc upon radius, and the value of arc is NL and the value of radius is r. So we will write the theta is equals to NL upon r and theta is equals to S by d. Now from first and second equation, theta will be equals to S by d is equals to NL upon r. Now what do you mean by sensitivity of bubble tube? It is generally represented by alpha. Now it is an angle of rotation due to one division movement. Just remember this, it is the angle of rotation due to one division movement of bubble on one side of the bubble tube. So we can write alpha as theta by n, because theta is the total rotation for n division. Now we have to compute the angle of rotation for one division movement, so we have to divide the theta by n. We will get the value of alpha as S upon nd is equals to L upon r. Now we know that in pi radian there will be 180 degree, so in 1 radian there will be equals to 206265 seconds. So we will convert the sensitivity value, that is S upon nd, from radian to seconds. We need to multiply it by 206265 and it will be in seconds. Similarly, by using the next formula, that is L upon R, we can get the value as alpha is equals to L upon R into 206265 in seconds. Now that is the sensitivity of bubble tube. Now one question is given, the staff reading taken from an instrument when bubble was at center on a staff kept at 250 meter. It means that the value of d is already given, that is 250 meter, which is shown here. Okay, the distance was 1.62 meter. It means that the value of S1 is already given. When the bubble was at center, the staff reading is 1.62 meter. Now the bubble was then moved by 6 division. It means that the value of n is given as 6 and the staff reading changed to 1.95. It means that the S2 value will be equals to 1.95 meter. If length of one division of bubble tube is 2.50 mm, it means that the value of small l is given as 2.50 mm. So we will convert this value into meter, that is 2.50 into 10 to the power minus 3 meter. Now we need to calculate sensitiveness of bubble tube, that is alpha value, and radius of curvature of bubble tube, that is r value. Now we know that alpha will be equals to S upon nd into 206265 seconds. Okay, now the value of S will be equals to S2 minus S1. It will be equals to 1.95 minus 1.62. It will be equals to 0.33 meter. That will be the value of staff intercept S. So we will write it as 0.33 upon value of n is 6 and the value of d is given as 250 into 6265 in seconds. After solving this, we will get sensitivity of bubble tube or sensitiveness alpha is equals to 45.37 seconds. That will be the value of alpha. Now we need to compute the value of R, for which we know that the formula is alpha is equals to L upon R into 206265 seconds. Okay. Now we have the value of alpha as 45.37 seconds. We have the value of L as 2.5 into 10 to the power minus 3. Now we need to calculate the value of R, and here we need to multiply it by 206265 seconds. After solving this, we will get the value of R as 11.36 meter. That will be the radius of curvature of the bubble tube. So we had completely solved this numerical. That is all about the errors in leveling. Thank you very much, students.